Look up at the night sky, what do you see? Billions of stars twinkle back at us. They are distant suns. Each one is a potential home for worlds we have yet to discover. For all of human history, we have gazed at these lights. We have wondered about our place among them. This curiosity is written into our very DNA. It is the same drive that led our ancestors out of Africa. It is the same spirit that pushed explorers across vast unknown oceans. We are an exploring species. It is what we do. The cosmos is simply the next and perhaps the final frontier. This innate urge to explore has never been stronger. We are living in a truly remarkable era. The universe is slowly giving up its secrets. We are beginning to piece together the grand story of existence from the Big Bang to the present day. Every new image, every piece of data adds another sentence to this incredible cosmic story. We are not just passive observers, we are active participants. We send our robotic emissaries and soon ourselves to touch these distant worlds. We are reaching out to understand not just the universe but ourselves. It is a journey of profound significance. The scale of it all is almost impossible to comprehend. Our Milky Way galaxy contains hundreds of billions of stars, and there are perhaps 2 trillion galaxies in the observable universe. The numbers are staggering. They can make you feel small, but they should also make you feel a sense of profound wonder. We are living through a renaissance of space exploration. It is a new golden age, bustling with activity and ambition. At the forefront is NASA's Artemis program. This is not just about revisiting the moon, it is about going back to stay. Artemis aims to build a permanent human presence on our lunar neighbor. A new generation of astronauts will walk on the lunar surface. They will build habitats. They will conduct science in preparation for an even greater journey. The moon is a stepping stone. It is a training ground for the first human mission to Mars. This new era is not just being driven by national space agencies. A revolution is happening in the private sector. SpaceX, Blue Origin, Virgin Galactic. They are making access to space cheaper. They are making access to space more reliable. They are making access to space more frequent. We see rockets landing themselves back on Earth. This was science fiction just a decade ago. Now it's almost routine. This commercial drive is creating a vibrant economy in low Earth orbit. It is opening up space for tourism. It is opening up space for research. It is opening up space for new industries we can barely yet imagine. The sky is no longer the limit. Meanwhile, our robotic explorers continue their tireless work. On Mars, rovers like Perseverance are searching for signs of ancient life. They drill into the Martian rock. They are analyzing samples that could rewrite our understanding of biology. Perseverance even has a companion, a small helicopter named Ingenuity. It has proven that powered, controlled flight is possible in the thin Martian atmosphere. These missions are our eyes and ears on another world. They are paving the way for the first human footsteps on the red planet, turning a dream into a tangible engineering challenge. This magnificent observatory is a time machine. It is peering back to the dawn of the universe. Our ambitious dreams for space require equally ambitious technology. Future missions to Mars and beyond will take months or even years. We need to get there faster. This is where new propulsion systems come in. Scientists are developing advanced concepts like nuclear thermal propulsion, nuclear electric propulsion. These systems could dramatically cut down travel times. A trip to Mars could be reduced to just a few months. This would be a game changer. It would mean less exposure to radiation for the crew and a more efficient mission altogether. We are moving beyond the limits of conventional chemical rockets. Once we arrive at our destination, whether it is the moon or Mars, we cannot bring everything we need with us. It is simply too expensive and impractical. The solution is to live off the land. This concept is called in-situ resource utilization, or ISRU. It means using local resources to sustain a human presence. We can extract water ice from lunar craters or the Martian soil. This water can be used for drinking, for growing plants, and for creating breathable air. We can even split it into hydrogen and oxygen to make rocket fuel for the return journey home. Building a home on another world is one of the greatest engineering challenges we face. These habitats must protect astronauts from extreme temperatures, radiation, and micrometeoroids. Early bases will likely be built from modules brought from Earth, but future habitats could be constructed using local materials. We could use 3D printing technology to build structures from Martian soil or regolith. We are also designing inflatable habitats that can be launched in a compact form and then expanded to create large living and working spaces. These are the homes of the future. life in space for long durations presents unique challenges for the human body. We need to create closed-loop life support systems. These systems will recycle air, water, and waste with near-perfect efficiency. This is essentially creating a miniature Earth ecosystem inside a spacecraft or habitat. We are learning so much from the International Space Station. It has been our laboratory in orbit for over 2 decades. The lessons learned there about human health, life support, and long-term habitation are absolutely vital for our next steps into the solar system. We stand at a unique moment in the history of our planet. For 4.5 billion years, life on Earth has been confined to this one world. But now, one species, our species, has developed the capability to leave. We have the technology, we have the knowledge, we have the ambition to take that next step. This is not just an opportunity. For the long-term survival of our species, it is a necessity. Spreading out into the solar system is the ultimate insurance policy. It protects us from cosmic threats, it protects us from terrestrial threats. This journey into space will change us. It always has. Seeing Earth from afar, the overview effect, profoundly impacts astronauts. It fosters unity. It fosters a deep appreciation for our fragile planet. As more people travel to space, this perspective will spread. As we establish communities on other worlds, the view will become common. The challenges of exploration will force global collaboration. In reaching for the stars, we might find a better way of living together here on Earth. The future of humanity is linked with space exploration. It is a future of wonder and boundless possibility. We will make discoveries that reshape our understanding of the universe and reshape our understanding of our place within it. We may even answer, are we alone? Imagine the moment we find evidence of life, even simple microbial life on another world. It would change everything. It would connect us to a larger cosmic story of life. This is the prize that awaits us. Looking into the vast, dark expanse, we are not looking into an empty void. We are looking at our future. The path ahead is long and challenging. It will require the best of us. It will demand courage. It will demand ingenuity. It will demand perseverance. But it is a path we must walk. We are driven by a curiosity that cannot be contained. We are explorers at heart. The cosmos calls to us as it called to our ancestors. The next great leap for mankind is not a question of if, but when. If this inspired you, like, subscribe, and tell us your thoughts in the comments.